This is AP Calculus, lesson 2-1. We are on standard F. This is our brand new unit. So where are we in our unit guide, which I forgot to print. I'll print those at the end of the day. So 2-1, basic derivatives, basic power derivatives. So we're just dealing with basic derivatives for, what is this? We have, 7 out of the 10 lessons. So most of the lesson. All right, so you already have the setup. Let's knock down the setup. So if I have x to the power of -4, I can rewrite this with a positive exponent by writing this as what?
1 over x to the 4.
1 over x to the 4. You nailed it, Ben. Arrow, you do this one.
1 over x to the third.
1 over x to the third. And finally, this is the tricky one. This is the one that I think I saw the most mistakes on last year. Who wants to do this one? Okay.
2 over x to the 8.
2 over x to the 8, yeah. So the error, so you have it correct. The most common error is bringing the 2 down with the variable. And that's where hopefully we'll never do that for this class because we know how to do this correctly. But yeah, so in order to change the exponent from a negative to a positive, and let me just type in here, switch only the variable. And then the word switch is talking about from numerator or denominator. Numerator slash denominator. And the key word here is switch only the variable. So I'm going to underline variable. Don't switch the constant. Don't switch the number that is in front. Don't switch that coefficient.
So does that mean if you had a negative exponent in the denominator, you just move it to the numerator?
Exactly, yeah. So you're saying this type of problem, if I had 1 over x to the -2, then yeah, that turns into just x squared. All right, so everything on this slide, in the first slide, is just review. So roots. If I have something like, let's do the square root of x. Can I write that without any root? Can I write it in terms of a power?
X to the 1/2.
X to the 1/2. Exactly. Arrow, let's try you. Let's do the cube root. Let me write this. Cube root of b is equal to what?
B to the 1/3.
B to the 1/3, exactly. So in summary, let's do 1/3. In summary, you basically do whatever power this was, b to the 1 divided by whatever this was. This is, oh man, my vocab is failing me. Summer has been harsh. It's like the index, I think, or the indice. Yeah, so this is the index, I believe, of the square root. So it's 1 over the index. So as the final example, let us do x cubed 4th rooted. Anyone want to solve that one? X to the 3/4. Perfect. Yep. So it looks like we don't need any review on that. Let's go to derivative notation. Again, review from before. How do I pronounce this thing? F prime of?
X.
Yeah, so F prime of x. I'll put that in quotes. That's how I say that thing when I'm in math class. I don't even know what else I would say. Yeah, you don't say F apostrophe x, exactly. Another way of doing the derivative is like this. So when you're in college, this can actually be pronounced 2 ways. You can obviously just see, or you can speak what you say. So d dx is sometimes how I'll pronounce it, and in college you'll hear the same thing. But I prefer saying this thing like this. Derivative of x. Derivative, I guess not of x, but derivative with respect to x. With respect to move respect to x. That means, let's try it out. And I don't want to write these in our notes, so I'm going to do this in, I'll just do it in red and then I'll undo it. So don't write this in your notes, I just want to practice. So what am I doing? Someone try to pronounce this, and then whoever's next will do the next one. Perfect. And let's give you a slightly harder one, arrow.
Derivative with respect to y of y squared.
Perfect, yeah. So we understand how to pronounce these things. Now that we know how to talk about math, let's learn our actual lesson for today. So the first rule, the easiest rule, is the constant rule. Let's look at 3 examples. So I'm going to do these in black. Example 1, example 2, and example 3. Example 1. The derivative with respect to x of 5. The derivative with respect to x of negative 2, and the derivative with respect to x, d dx, of k. I will solve each of these for you, and you can see if you can figure out the rule. The derivative with respect to x of 5 is, oh wait, hold on. I'm pausing because you need to catch up. The derivative with respect to x of 5 is 0. The derivative with respect to x of negative 2 is 0. The derivative of any constant k stands for constant, so I'm going to spell it like this, constant. Yeah, it's spelled with a C normally, but well, yeah, constant is what? It's 0, yeah, anything is 0. So we can make this even more formal. We'll do like our giant red star. This is important. The derivative with respect to x, and even with respect to y, but for the sake of the lesson, just with respect to x of a constant equals 0. Always, always, always 0. All right, let's learn our next rule. I'm going to call this the linear rule. And we'll come back to why I'm calling it a linear rule. I mean, this one was a constant rule because it was the derivative of a constant. These are our basic power derivatives. So derivative of a linear function is the reason that we give this the name. And I'm, again, going to do 3 examples, and then we'll generate a rule from it. 1, 2, 3. First one, derivative with respect to x, d dx of 3x. Derivative with respect to x, d dx of negative 2x. I put parentheses because maybe it's hard to see the negative. And finally, derivative with respect to x, d dx of, let's do a harder one. I'm thinking 12x plus 1. All right. See if you can find the pattern. The derivative with respect to x of 3x is 3. The derivative with respect to x of negative 2x is negative 2. The derivative with respect to x of 12x plus 1 is 12. Do we see the pattern?
The coefficient.
Yeah, you're just taking the coefficient. So our rule, d dx of some number box x is equal to whatever that box was. You just take the coefficient. So I'll write that on the side note. Take the coefficient. All right, so these 2 things are nice, but there's actually one rule to rule them all. And in the darkness bind them. So what is that one rule? And I'm going to call it the simple power rule. This is our last slide, I believe. Let me just double check on that so I'm not lying to you. I'm not lying to you. This is our last slide. Simple power rule. All right, so this is, I guess if all those other 2 got their own star, this one is a double star then. I don't even know what you have to do in Grand Theft Auto, get 2 stars. Anyway, so the rule here is the derivative with respect to x of, let's assume that our coefficient is 1. Normally, in your textbooks, it'll look like this. X to the power of n is equal to blah. I'm going to make a coefficient 1x to the power of n, just to assume that there's nothing down there. This is going to be equal to n times the quantity of x to the power of n minus 1. This is the rule that we will drill into our brain. But the nice thing about this one is once you understand the process, you don't actually have to memorize the notation here, which is kind of nice. Let's do like a ton of examples here to explain how this rule works. Examples. So let's take the derivative with respect to x of x to the power of 5. And this is a little bit weird, right? So we did something with x to the power of 0 right here, something with the power of 1. Now we're jumping all the way up to the power of 5. How do I do this? And I want to see if any of us two can do this problem. Just using this rule. So I take this n and bring it down in front. This n went down in front. That's where that n came from. So the coefficient here is what?
5.
Yeah, 5. And then you copy down the x, so it's 5x. And then what power is the 5x to?
4.
To the power of 4. I went down a power. So bring the power down, subtract the power. Let's try another one. d dx of x to the 40. Going crazy. Arrow, you try this one.
Um, 40x to the 39.
40x to the 39, yep. And let's try one where the coefficient is not 1 to see what happens. d dx of, let's do 3x to the 7. Either of you can take a shot at this one. Good guess. So you're saying 3x to the negative 4, but that's not quite right. Or 3x to the 4th is what you said, right? Not quite right. So again, I'm just...
3x to the negative 4.
Or 3x to the negative 4. Yeah, that's not quite right either. Again, I'm going to bring the power down, 7, and I was multiplying by whatever I had. So 7 times 3 to get 21, and I do x to the power of 6. I bring down the power, I multiply it by whatever the coefficient was. So 7 went down, 7 times 3, 21, and then it used to be to the power of 7, now it's to the power of 6. All right, let's do a different type of notation. Let's say we had f of x was equal to 2x to the power of 5. I want you to find f prime of x. Either Ben or Arrow can answer this one. Very similar to the last problem, different notation now.
Is it 10x to the 4th?
It is 10x to the 4th. And then I'm going to give one to Arrow, and Arrow, you're going to get the harder one, sorry. f of x
That's why I always answer the first one.
is equal to square root of x. What is f prime of x? This one is hard because we don't have any rule that deals with square roots, but maybe there's some reason that we reviewed it over here. What am I going to do to this one?
X
To negative 1/2. You are 100% correct. Yep. And usually that's okay, but for my class, I don't like negative exponents. Whenever you give me an answer in AP Calculus, get rid of the negative exponent. So you're correct. I'll accept that because that is mathematically correct, but now I've added a new constraint. So how am I going to convert this? Using the other rule with negative exponents. And either of you can answer.
1 over
1 over 2 square root of x. Yep, and that might be a little bit hard to see, especially for anyone else that's watching the video. But what happened here, let me do these steps in green, was it went 1 over 2 x to the 1/2. The 1/2 x, or the x to the 1/2 was brought to the denominator because of the negative exponent. And then from there, we went here, x to the 1/2 is the same thing as square root of x. Yeah, and this is the form, I mean, in textbooks, they usually just say this. They say f of x equals square root of x turns into 1 over 2 square root of x, and there's not a clear explanation why. This is the explanation why, and you can see all the steps to get there now. That concludes the notes. Are there any questions before we write summaries? All right.